All right, we're taking a look at 5.3, continuing to work with exponents and exponent rules, properties of exponents. Then first thing we're going to do though is we're going to revisit some concepts from 5.1 because you will be 5.2 because you will be practicing that in Delta Math. So you'll be given a problem like this. It says write the following expression without negative exponents and without parentheses. So again, the idea in 5.1 was that if we have a negative exponent, it's in the wrong place. So right now all of this is sitting, all of this is sitting over 1, and my x to the negative first power is in the wrong place, so I need to move it downstairs to make it positive. And then 4 is still on top. And then the way you would submit your answer is you would type 4, and that would go here, so 4, and then you would hit divided by, and what that's going to do is it's going to create a fraction, so it'll make 4 over, and then you're going to hit the x button because it's over x, and this one's to the first power, so you don't need to designate to the first power because it's already in that power. Okay, for something like number 2, this trips students up a lot. We have a negative 5 here, but that's just the value of our 5. It's not a negative exponent, so it's not telling us that it's in the wrong place. It's just telling us that it's a negative 5. X to the negative first power, when we have a negative in our power, that's what's telling us it's in the wrong place. So my red negative 5 is going to stay on top. My blue x to the negative first needs to move down to become positive. And again, the way we would type that in, we would hit negative 5, and that would give us this, negative 5, and then we would hit divided by, and that's going to create a fraction. And then we would hit x, and this one's to the first power, so we can just leave it like that. And then you would hit submit. Okay. Hopefully you're seeing the pattern here. My 5 has a positive exponent, so it is in the right place. It does not need to move. It's happy where it's at. My x to the negative second is in the wrong place, so I need to move it downstairs to make it x to the positive second. Here's how you're going to type that into the keyboard. You're going to hit 5 divided by, so your top value divided by, and that's going to create your fraction, 5 over. And then you're going to hit x, because that's our variable down here, so 5 over x. And here's the new part. This x is to the second power. So you're going to hit this a to the b power button. And what this is telling the computer to do is to create an exponent. So wherever your cursor is, which if you hit it in order, so you hit 5 divided by x, that creates this, and then you hit a to the b, and that's going to give you an exponent here. And then you're going to hit 2, and that's going to create a second power. All right, and then finally this one, again, we have 4 that does not need to move. He's happy where he's at. But x to the negative second is unhappy where it's at, so it needs to move downstairs to become positive. And again, here's the order we would hit our numbers. To punch them in, we have 4, so I would hit 4 over, so I'm going to say divided by x, and then to the second power. So I'm going to hit a to the b and then 2. So it would be 4 over x squared. So this would be the first button I hit, second button I hit, third button I hit, fourth button I hit, fifth button I hit. Okay, let's talk about our new 5.3 stuff. Okay, so we're going to be learning how to raise a power by a power. And that's going to help us simplify these expressions. And we'll be able to do it when we can rewrite and simplify an expression that has the power property. So negative exponents, remember I just went over that. So when we have a negative exponent, it needs to move to the other side of the fraction. That was 5.2. 5.1 was the product property, which is where we multiply our base numbers and add our exponents. Those are our little numbers. Raising a power by a power, and actually maybe I'm just going to write a little example here. So this would be like 4 to the x with a negative 3, which really means 4 stays and x to the negative 3 needs to move downstairs. For product property, that would be like when we had like let's say 2x to the third y to the second times 3x y to the third. And this was the one where we multiplied our bases, so we do 2 times 3 to get 6. And then we add our exponents. So x to the third and x to the first make x to the fourth, 3 plus 1. And then y to the second and y to the third make y to the fifth. We add our little numbers. So we multiply our base numbers, we add our exponents of like terms. Okay, so let's talk about raising a power by a power, or the power property. This is what it's going to look like. You're going to have a value inside your parentheses and then a power on the outside. And what this is saying is it's saying there are 3 sets of 2x to the fourth. So what it means, when we expand it out, it really means 2x to the fourth times 2x to the fourth times 2x to the fourth. Okay, and having 3 sets of that, we could then use our product property and multiply 2 times 2 times 2 and then add 4 plus 4 plus 4. But there's a shortcut. And the shortcut is when we raise a power by a power, the shortcut is we're going to distribute the power of 3 to every term in the parentheses. So the 2 is going to get a third power, and the 4, x to the fourth, is going to get a third power. And any existing power gets multiplied. So if I'm given this problem here, I'm going to take this 3 and I'm going to give it to the 2 to the third. I'm going to take this 3 and I'm going to give it to x to the fourth. And I'm going to multiply my little numbers. So 4 times 3 is 12. So let's go over a couple practice examples. And for these ones, we're actually going to also evaluate like what 2 to the third is. So we would take this a step further and say 2 to the third is 8x to the 12th. And I'll show you how to do that on the calculator. So for this one, we have a fourth power. So I'm going to give it to my 4 here. So this is going to be 4 to the fourth power. And I'm going to give it to y to the fifth. So that's going to get times 4. So if you see in purple there, I just took it and I distributed it to each term. Now I'm going to work this out. 4 to the fourth power. On Delta Math, I just have a random Delta Math problem pulled up here. But you can see I have a calculator down below. I'm going to hit 4. You see it pop up over on the bottom left corner here. 4 I'm going to hit that power button, A to the B, and then I'm going to hit to the fourth power, 4 to the fourth power, and if you look on the far right, it's telling me that's 256. So 4 to the fourth power makes 256. You can just punch it in the calculator in Delta Math. And then we're doing 5 times 4, so that's going to be y to the 20th. So let's see another example here. I have individual terms. I'll highlight them just so you can see them. That 3 is its own thing. X squared is its own thing. And y to the fourth is its own thing. So every single one of these is going to be given this 3 on the outside. So this 3 is going to go here, so it's going to get 3 to the third power. 3 is going to go to x squared, so it's going to be x squared times 3. And 3 is going to the y to the fourth, so that's going to be y to the fourth, 4 times 3. Okay, so 3 to the third power, I'm going to go back over to my calculator just to show you. I'll clear it, and I'm going to say 3, a to the b, 3. 3 to the third power, and that's telling me it's 27. You can hit enter if you want and get your row there. 3 to the third power is 27. And then I'm doing x to the 2 times 3, so 2 times 3 makes 6. Y to the 4 times 3, which is 12. All right, just a couple more examples here. So I have 3, and I have y to the 6th. So I have a 3, I have y to the 6th, and both of them are getting a power of 2. So 3 to the second power means 3 times 3, which is 9, and y to the 6 times 2, 6 times 2 is 12. So we get 9y to the 12th. Again, I'm going to have 4. I have x to the 5th. I have y to the 2nd. And all of them are being raised by a 4. So I have 4 x to the 5th times 4, y to the 2nd times 4. So 4 to the 4th, we already worked that one out, but I'll show you again on the calculator. We're saying 4 raised to the 4th power, and that's 256. X to the 5 times 4 is x to the 20th, and y to the 2 times 4 is y to the 8th. So let's see some actual Delta Math assignment type questions. So this is what you would do on a separate piece of paper when you're working on the Delta Math. I would take each individual term. So I'm going to write 3 times x squared and y squared. And then I'm going to give each one of those a third power. So 3, like that. And then you'll work out. So 3 to the third, you'll pull up the calculator. You can say 3 raised to the third power equals 27. You're going to do x, 2 times 3 is 6. Y, 2 times 3 is 6. So that would be your answer here. Remember, we're hitting that x, and then you're going to hit the A to the B button to put a 6 up there. Then you'll hit the right arrow to bring the, because your cursor will be up here. You'll you'll hit the right arrow so that you can type Y, and then A to the B button, 6. Typing it in is kind of hard, but we'll work on it together. Okay, so you may end up getting a negative here. So this -3, we're going to square that whole thing. So that -3, x to the 4th, y to the 3rd, and all three of them are getting a 2. So to the 2nd power, so -3 to the 2nd power in the calculator, you're going to want to use the parenthesis button, -3, then a to the b, and we're saying to the 2nd power, and that's going to give us a +9. So I get +9. X to the 4 times 2 is x to the 8th, and y to the 3 times 2 is y to the 6th. So you would type that in, you would hit 9, you would hit x, that a to the b power button to put your exponent, which would be 8, then hit the right arrow to drop back down. You're going to hit y, you're going to hit that a to the b button again, and put a 6. Okay, just do a couple more examples here. So we have a 3, we have an x to the 5th, and we have a y to the 1st. And all three of those are getting a 5. So I'm going to give that a 5, that a 5, and that a 5. 3 to the 5th. Come over to the calculator. I'm going to hit clear. I'm going to say 3 raised to the 5th power, and that's 243. So the calculator will do it for you. X to the 5 times 5, which is 25, and y to the 1 times 5, which is 5. So 243, x, you're hitting that a to the b button, right arrow to bring it back down, because otherwise if you don't hit the right arrow, it's going to say it like y like that, and that's no good. So you have to hit the right arrow, y to the 5th, a to the b button, 5th. Let's see, this will be the last one that I do. Okay, so I have a 6, so I'm going to write 6. I have an x to the 3rd, I'm going to write x to the 3rd. I have y to the 3rd, so I'm going to write y to the 3rd. And all three of these are getting a 5th power. Six to the 5th, I'm going to work out in the calculator. No use in just trying to multiply 6 5 times. I'm going to say 6 raised to the 5th power, 7,776. So 7776. So the number is large, but the process in the calculator is the same. Okay, x to the 3 times 5 is 15, y to the 3 times 5, which is also 15. So in my answer, I'm writing 7776. X, I'm hitting that a to the b button, putting a 15, hit my right arrow, a y, and then a to the b button, 15. Okay, and if you need help with the calculator or any part of this, please just let me know as you work on it on the independent practice.